Okay, welcome. This is lesson 12. Lesson 12, and we are talking about exponents. We are changing exponents now. We're going to be converting them to radical form. So, radicals have indexes. So, what we're going to be talking about, first of all, is what is a exponent of fraction. That's what we're going to be talking about, is creating fractions as our exponents. Well, up to this point, we've only had exponents that have been whole numbers. Then we started dealing with negative exponents. That was our last couple lessons, dealing with negative exponents. So if we look at a negative exponent, if I go 5 to the negative 1, everything is over 1. I can always turn it to a positive exponent. We always want to have positive exponents as our final answer, okay? So that's the idea. So that's what we did before. Now what we're going to do is we're going to find out, how can I create the digit 1? Well, you can create the digit 1 by doing halves and partials. So if I've got a square root 2, this is my index. And what we're looking for, I'm just going to show you real quick up here. If you take a look at the index and the exponent, index and exponent, and look at what happens after. I end up with square root 25, because I multiply my 5s, 5 times 5. Did I multiply the root signs? The indexes, I did not multiply them. Now, if you have a double root, you would, but these are side by side. Side by side, you're not multiplying them, they stay the same. Now we would solve it. So we're going to solve it, and we get the digit 5 exponent 1. Okay, that's what we're trying to create, is 5 exponent 1. Well, how can I take that radical out of out of its root sign? Well, first of all, we have to remember that a root sign behaves like a bracket. So what's actually going to happen is the index is going to slide over under the exponent, and that's going to become the denominator, and your exponent will stay the numerator, and that's how you create your fraction. So your index is sliding over. I'm just going to draw it bigger so you can see. Whoopsie, the 5's in the wrong spot. So if I've got my 2, my 5 to the 1, this 2's sliding over, and he's going to go underneath the 1 to get rid of our root sign. And that's going to how we create a fraction. So 5 to the 1/2 times 5 to the 1/2, I would add exponents. So I've got 1/2 plus 1/2, that gives me 5 to the 1. And that's what we're looking for. We want to get 5 to the 1. How do we get that whole number exponent? We create it by taking the root signs, and we create the indexes as our denominator. So what if we have a different index? Same rule applies. So this guy's going to slide over. We have a hidden 1 there. This guy's sliding over under, and that's what we see right here. Okay, the index slides over, your root sign disappears. So now if I'm multiplying them, the rule is you multiply underneath. So 2 times 2 times 2 is 8. And the cube root of 8 I will solve and get 2 exponent 1. You never have to show those ones, but you have to know they're there. So now if I want to explain what is my radical, what would it look like without the radical sign? Well, the 3 is going to slide under and become a fraction. So now I've got 1/3 plus 1/3 plus 1/3. That equals 1 whole. So that's going to give me 2 to the 1, because you're going to get 3 over 3, and 3 over 3 is 1. Okay? So when you add fractions, you only add top numbers when your bottoms are the same. So what we're trying to find out is, we're saying, okay, well, what is the meaning of it? Well, what we're saying is, this is the same thing as saying root 5 to the 1, index of 2. This is saying cube root 2 to the 1. That's what that's telling me. So whenever I've got a fraction exponent, you're actually taking a root of it. So we're going to convert the following ones. We're going to do exactly what it is. If it's a fraction, the bottom number becomes the index. So the bottom denominator becomes the index. Okay, so the denominator becomes the index. So on this one, I'm going to have root 25 to the 1. Do I have to show that index of 2? No, the 2 is the only one that can hide. Then you would solve it. It says evaluate. That means solve it. So I'm going to solve it, and it becomes 5 to the 1. I will try and make it unglitch here. All right, the next one, same thing. The 3 is going to slide over and become the index. So my index of 3, 64 exponent 1. I take the cube root of 64. I'm going to get 4 to the 1. 4th root of 81. That's what the 1 over 4 is telling me. I'm going 4th root 81. And I type that in my calculator, and I'm going to get the answer of 3. Remember, all those numerators of the 1s, those are what's hiding on that inside digit. Now, any other number than a 1, they will show it to you. Now we're going to do it with variables. Nothing changes. Everything stays the same. The rule is the same. The bottom of your fraction becomes your index. He's just going to slide over. So this is going to become root x to the 1. Do you have to show either of those? No. In this case, the 1 as an exponent can hide, and the index of 2 hides. So this is your final answer. Yes, you can just write it like that. You don't have to show the 2 or the 1. It's not wrong if you do. The next one, we're going to get a cube root of b. There you have to show the cube root. Anything bigger than a 2, you got to show the index. This guy, craziness, we got a 10th root of letter P. And over here, this is our generic statement. We have the nth root of a exponent 1. Okay, that is our generic statement. So it says, what is the meaning of your exponent form? Well, the exponent form converts. It converts. So we end up with nth root, bottom number becomes the index, a exponent m. That's our generic statement. Does the top number of your fraction, is it always a 1? No. They can put different numbers up there, and it's totally fine. So we're going to take a look at the next one. How would I create fractions for those? Well, this guy's going to become 5 to the 3 over what? 2. The index that's hiding right here is a 2. So it's 5 exponent 3 over 2 times 5 exponent 3 over 2. When you've got exponents and you're multiplying, you add the exponents. So we're going to get your base stays the same, though. You're not multiplying the 5s. The 5s stay 5. They're not going to change to a 25. And then we're going to add the exponents. So we're going to end up with 6 over 2, because when you add fractions, you only add the tops. Now, could I put that in my calculator? Absolutely. This will solve evenly. You always solve or reduce your fraction, because that's a rule with fractions, and that rule never, ever leaves us. So whenever we're dealing with fractions, we always have to reduce it. 6 divides by 2 evenly. So this is going to become, whoopsie, where's my color? This is going to become 5 cubed. And now it says evaluate that. Well, that's going to become 125. That's what it would solve to. So now they're showing us, well, can I just do it, if it's no root signs, can I just do it with fractions? Well, absolutely. This is going to give me 3 over 2, 3 over 2. I get 6 over 2, which is 5 cubed. Solved to 125. Same rule. So what is the meaning of that? The meaning for this is root 5 cubed. That's what they're saying. Root of 5 cubed. So that's like saying the root of 125. So this becomes the root of 125. Hang on, I'll write that a little better. Root 1, 2, 5. There. It's not messing up too bad now. Okay, let's take a look at what happens with the 2's. Well, if I ended up with just 5 to the 3, and I had 2 of them, what do you think this next one's going to end up with? What do you think it'll end up with? Just what's underneath it, right? So it's just going to end up with this. That's all you're doing. So if I go 2 squared, how big is 2 squared? 4. So this is saying cube root 4, cube root 4, cube root 4. So literally it's saying 2 squared is 4. So we know underneath that cube root sign, it is a 4. So now if we take it out and we use the fractions, we've got 2/3 plus 2/3 plus 2/3. Now our top number we're going to end up with 6/3, which is equal to 2 squared, which is what we started with under there, which is equal to 4. So the meaning of this, they're saying, is cube root 2 squared is the same as saying cube root 4. That's what they're telling us. Yeah.
So for root signs, are you always going to end up with the same number you start with?
It depends. If it's multiplying by the same one, yes. Yeah. Okay. Now, if I solved it, when we multiply, no, we won't go that far. It's okay. You just need the base. No, I won't go that far. It's okay. Okay, now let's do letters. If we do letters, the same thing's going to happen. So the bottom number slides over, becomes the index. So this guy is going to be an index of 3. This guy is an index of 5. Index of 2. Indexes of 2 you don't have to show. Okay, so I drew all my indexes. Now you're putting the radicand. The radicand is what's left over underneath. So left over underneath, I'm going to have x to the 5. Here I'm going to have b to the 4. Here I'm going to have letter p exponent 5. And over here I'm going to have a exponent m. So this is, again, just showing us our generic form that those are equal. Okay? Turn your page. So now we're going to square it, and we're going to come up with a whole bunch of different things. We want to see what is happening if you've got an exponent outside of brackets now. That's what it's showing us here. So it's saying, okay, we're starting with this. What could that be equal to? Well, it could be equal to this. What happens when you multiply fractions? This right now means my 2 has to multiply in. So if I'm taking 2 and I'm multiplying it by 1/3, what's actually happening is this, 2/1. So you multiply top numbers, multiply bottom numbers. So that's going to become 2/3. That's what they're showing, that this is equal to this. That's why. So what's going to happen is when your fraction's there and you have an outside exponent, if your outside exponent is an integer, so not a fraction, positive or negative, you're going to multiply it to the top number only. So that's what ends up happening is the exponent number here, that was your exponent, it's going to multiply to the top number always. Okay? Does it end up multiplying to the bottom? No, because it's a whole number to start with. So that means the number on the bottom, if you put it to a fraction, is a 1. So that's why it's always going to multiply to the top number. So now we're going to rationalize this in a sentence and try and figure out what is this trying to tell me. So what is my equal form? So if I said, what is my equal form of that? I'm going to put a hidden 1 on this guy. I'm going to change him to fraction form. That makes this guy 8 to the 1/3, all now times 2, which is what they're doing here, which gives me 8 to the 2/3. Now, because it's the cube root sign, if it's a cube root sign, just like we did with our cube root 2 on the other page, if I had cube root 2 times our cube root 2 and it was squared, what ended up happening, our answer was what was underneath. It's your radicand. So if I want to convert, so let's take a look at this again. We're converting, and they showed us this form. I'm going to take my box away from it. So they showed us this form first. I'll box it again. And when you do that, what it's showing us is the top number there, that ends up being the answer because the bottom number ends up being the index. So that means I forget about that number. My 2 is going to multiply to my 8, and that ends up becoming, I take my cube root of 8, which is 2, and now I square it, which is 4. So let's just redo that real quick. When it's in a cube root sign, whoopsie, that's not my eraser. Let's do this a little slower. If I've got a cube root sign and it's a perfect cube, just like a perfect square, square root 25, you solve it. This is a perfect cube, cube root 8. So this means solve, because square root signs and cube root signs, they behave like brackets, which means in BEDMAS you have to solve it first. So before you can even multiply that outside exponent in, exponents don't come first in BEDMAS, brackets do. So that means your radical comes first. So that means the inside of your bracket, you need to solve this because that's back to BEDMAS. So write your little hint to yourself. You still use BEDMAS. Still use B. Come on now. E. Oh, glitchy glitch.
Oh, I saw 3.7.
Okay, so we still use BEDMAS. And like I said, brackets, your root signs behave like brackets. They must be solved first. So I solve him, and I'm going to get the number 2. The 2 has a hidden 1 on it. He's still in brackets, and that outside 2 now is going to multiply to the 1. So now I've got these two. We're using exponent laws. They're multiplying. And that's how I end up with this. Okay? We're going to do another example right after this. Hopefully it'll clear it up for you. If it's a perfect cube, you solve it. Just like perfect squares, you solve them. So now we're going to deduce a meaning for it. So this guy here, what if you now put a 2 on it? What ends up happening to that guy? Well, this 2, what did we notice here? This outside 2 ended up, yes, being the exponent on the answer of your radical. So I need to answer my radical, and then the 2 ended up there. Is that going to change how we solve the question? Well, let's take a look. We're going to solve it first because, again, BEDMAS. BEDMAS means I need to solve my bracket first. Okay, BEDMAS. Solve your bracket first. So that's why over here I solved, and now I'm solving in the bracket. That's going to give me 64 to the 1/3. Okay, 64 to the 1/3. That's what that's going to give me. So that means this guy, 8 squared, is 64. So that's the same as me saying cube root 64. I'm putting a 64 where the 8 squared was. 8 squared is 64. Now, it has a hidden 1 on it. If I put that as a fraction, that means cube root that number. Well, we know that perfect cubes and perfect squares, you solve them. So this guy now has become a perfect cube. Cube root 64 is a perfect cube, so we have to solve it. Perfect cube means solve. So I'm going to get 4. So 2 different ways to do the question. You can do it where you're using your fraction laws, and then you do your BEDMAS, solve the radical first. Or you use exponent laws, solve the exponent in the bracket first, and then use your outside exponent. Both ways are correct. They're both using BEDMAS. So whichever way your situation is written on the page, you have to follow the BEDMAS rule. So this guy is saying the answer of that is 4. It's saying the answer of that is 4. Well, how come? Again, because it turns it into a cube root. Let's take a look at a couple more examples. It'll hopefully make more sense. This guy says square root of 64 cubed. That's where the numbers would go. The top number, the exponent stays on top. That's your top number. Okay, the bottom number slides over to the index. So now we're going to solve it because it's BEDMAS. So this guy here, 64 cubed. In your calculator, somebody grab your calculator and go 64 cubed. What's 64 cubed?
262,144.
Okay, it's big. And it's still under the root sign. And now we're going to square root it. 262,144. And now we square root that number. So I square root that number. What are you going to get? 512. Okay, so again, it's just being able to use your calculator. Now, could I solve that by typing in the fraction? Absolutely. Let's go to our calculators. We're going to type it in both ways. So the first way I'm going to type it in is I'm going to go 64 exponent. Now remember, brackets for fractions. Open a bracket, and I'm going to go 3 divide 2, close my bracket. Now I hit enter. It's going to give me 512. So your calculator will solve these for you, but you have to understand, why is that giving you 512? Because you're solving what's under the radical first. Okay? Now, the other way to do that, what happens when you have an outside exponent? It gets multiplied into the inside exponent. Let's take a look at this one. This is going to be square root of 4 all to the 5th power. You can write it this way, or square root 4 to the 5th power. So both are correct. This one here has a 1 on it, and the 5 would multiply in, and it becomes this. Okay, so if you understand that the outside exponent's multiplying into that 4, you could actually do it 2 ways. So I could go square root 4, solve it, I get a 2, and then go exponent 5. Or you can go 4 exponent 5 and then square root that answer. This number will always be bigger. This number will simplify quicker. You're going to see it both ways. Simplify quick. So if you like to do the simplify quick, that's totally fine. Just leave your exponent on the outside, which is fine. This one, let's try it the quick way. So I would have this, 81, exponent 1, and I'd leave my 3 on the outside. Whoa. Hang on. I'm going to leave my 3 on the outside. And now I'm going to go 4 through to 81. 4 through to 81 should give me a 3. It's still in brackets, and now it's cubed. So 3 cubed will give me 27. All right. Taking a look at the next question. If we look at their opposite signs, if I take a look at this, what does 5 plus negative 5 give me? 0. So when you look at it at the number line, if I look at a number line and I say that 0's in the middle, here's negative 1, here's positive 1, it doesn't matter as long as the numbers are identical. I could say that's negative 1/3, positive 1/3. They're going to be an equal distance away from 0. So what that means is when you add those two numbers, they're going to end up at 0. So I add those together, they end up at 0 as my final answer. So whenever you get a fraction and his opposite, or any digit and their opposite sign, you're always going to get a 0. 6 and -6, 0. 2/3, -2/3, 0. So that's going to give us 8 exponent 0. And what do we know about that? Right, everything disappears. So now all of it disappears and becomes the digit 1. Okay? Now we're going to write it as a positive exponent. So if I want a positive exponent, this is over 1. If it's over 1, how do I make an exponent positive? Flip. So I'm going to flip this guy, and that's going to give me 1 over 8 to the 2/3. Okay, 1 over 8 to the 2/3. 2/3 is positive now. So now if it says convert to radical form and evaluate it without a calculator, well, that means I have to do this. That's going to be 1 over cube root 8 all squared. Well, we know cube root 8 is a perfect cube, which means we have to solve it. Because again, we're doing BEDMAS. And that means we solve our radicals, just like brackets. They go first. So I'm going to solve that bad boy, and he's going to become a 2. So I get 1 over 2 squared, which is 1 over 4. So my final answer for this one will be 1 over 4. Okay, so that's evaluating it without the calculator. Now, you can type it in the calculator and it'll give you 0.25 right away, and then you put it into a fraction. But you need to know how to do this algebraically because you're going to be given questions. All right, Jace did it one way, Loden did it the other way. Who did it right? Who made the mistake? Okay, so you're going to be doing questions like that. So that's why we do have to know the longhand. All right, so this is now our general expression on rational exponents. These are the rules. Okay, we've been just investigating these rules, but these are the actual rules of what they're telling us. So they're saying that our bottom number becomes your index. Top number becomes the exponent. And what are we noticing? They're putting the exponent on the outside of a bracket. Why are they doing that? There's a reason. Why is that exponent going on the outside of brackets? Why is it only bracketing the radical? It's doing it on purpose. How come? So that it gets everything. You're on the right track. It's on the...
Do it the inside bracket first.
Yes, it's all because it's BEDMAS. You have to solve the inside bracket first. Okay, so that's why they will always do brackets. When you insert something, it's always in a bracket. And we know fractions are also always in a bracket. So that means the reason they're putting it in a bracket without this exponent on the inside is so that you will solve this part first. Why is it not writing? Solve it. So that's what it means. Solve that first, then put the exponent on. That's going to reduce the amount of mistakes you make because that's going to reduce the amount of work. Okay, it simplifies it quicker. That's the shorthand. All right, and then it shows us our negative exponents. Well, what happens with the negative exponent? All it does is it ends up on the bottom of a fraction. So it just puts this guy over 1, and then what do? We know we flip that bad boy. That's all we're doing. Okay, so that's why they're saying it's equivalent. Now, what have they done? We've got a 1 there. This m is multiplying to the 1, so it becomes this. Okay, so you can see it with a bracket on the bottom, but if it wants your general answer, it'll leave it like that for you. Okay? All right, so we're going to evaluate these guys longhand without a calculator. Here we go, folks. So the first one, convert to radical form. Index of 2, 25 cubed. Okay, so always put your information in a bracket first. Outside exponent goes outside of brackets. We're going to solve it. That's going to become 5, and now he's cubed. 5 cubed becomes 125. So 125. Okay, let's try the next one. So the next one, we're going to see 3 zeros, and the bottom number is a 3. So we're cube rooting the number 1,000. And again, the 4 is on the outside of a bracket. So that means solve your perfect cube. Solve our perfect cube. He solves. He becomes a 10. Now I'm putting that 1 as my, that 4 as my exponent. So now my exponent is 10 to the 4. 10 to the 4 is going to be how big? 10,000. You solve it. So whenever you're dealing with powers of 10, you use the number 1, and the exponent tells you how many zeros. So that's going to be 10,000, 4 zeros. All right, the third one, C. It's negative. So first of all, we need to flip that bad boy. So this guy's going to become 1 over 27 to the 2/3. That's what's going on. Now we get rid of that fraction exponent. So now we're going to have 1 over cube root 27 in brackets exponent 2. So now you take the cube root of 27, you actually solve it. So we're going to solve that sucker, and we're going to get a 3. That 2 now sits on that 3. So I have 2 squared. That's going to give me 9. So he evaluates to a positive 9. Let's try to box or circle our final answers. Whoa, not like that. So that we can find them right away. We don't have to search for them. Let's try and box them. Circle them. So you know where they are. Okay, same thing. The next one, he is negative. So you got to convert him, which means we flip it. So this guy's going to be 1 over 16 to the 3/4. Positive. Now we're going to get rid of that fraction exponent.
The previous question would be 1 over 9.
Oh, yep. Thank you very much. That guy's still in a fraction. Thank you, sir. We have a 1 on top still. So it's going to be 1 over 9. We still have that 1. We're in a fraction. Same thing on this one. We're going to take the 16 and we're going to 4th root it. So we're going to go 1 over 4th root 16 cubed. Now we solve 4th root 16 on your calculator if you solve it. Or if you look on your green sheet, it'll tell you the answer is 2. And now we put the exponent 3 on the 2 and we solve it. So that's going to give us an answer of 1 over 8. 1 over 8. 1 over 8 tells you that it was a negative exponent that got flipped whenever you see a situation like that. Okay, letter E. Again, it's a fraction, so we have to convert it to exponent form. It's exponent form. We're converting to radicals. We have a negative 8, and now it's all squared. We're allowed to put negatives under radical signs if it's an odd exponent. It is an odd index. So now I'm going to solve this guy. He's going to become negative 2. My exponent comes down, and I'm going to get negative 4. Positive 4. Because this guy's still in brackets. So that means you've got positive 4. So when you solve that number, remember, that's why we're using brackets. Every time you insert something, it's inserted in a bracket.
Well, when the man's gotta go,
Okay,
he's gotta go.
that's right. Sometimes for sure.
Off to pursue his educational prowess.
Yeah, exactly right. Okay, so let's take a look at letter F. Letter F, and don't forget our brackets. We can't forget brackets. So this guy, is the exponent negative? No, the exponent's not negative, so I'm not flipping it. I'm not putting it over 1. Yes, the 8 is negative. That's okay, because when I convert it to radical form, it's going to be a negative 8 underneath, and that's okay. Squared. Why do they have the same question twice?
One's bracket.
Oh, one's bracket, one's not. Sorry, thank you. So the other guy's a floater. So now this guy here, we're going to solve it. And the reason we're solving it, this guy here, he's outside. So they've actually left the exponent or the negative outside. So you're not bringing the negative under unless it's in brackets. So you have to take a special care about that. So everybody take a look. Highlight this. You only put your negative in brackets if it starts in brackets. If it's not, remember we call those floaters. And floaters always make your answers negative. So that's the difference between this one. That negative keeps flowing down. We're going to solve this guy. He's still in brackets. And then he's going to get squared. So our answer is a floater, so it's -4. That's the difference. The floater. Now, letter G, the only thing that makes letter G more challenging, again, is it's a lot of bed mass. And yes, bed mass always applies. So we have to solve in the brackets. So I look inside the brackets, and inside the brackets, I have lots to solve. So I go by bed mass again inside, exponents first. So I need to solve this guy and this guy first. So that's my very first step. 9 plus 16. All exponent 1/2. Okay, now we're going to add the 9 and 16 because it's in a bracket. We're going to get 25 in a bracket, all to the 1/2. Fractions also go in brackets. I just don't have room for it. This thing it glitches too much. All right, so now what we're going to do is we got to put it in radical form. So the 2 is going to become the index. So now this means I've got root 25, all exponent 1. Does that exponent 1 matter? No, not really, because everything has a hidden exponent 1. So I don't really need to worry about my exponents. I just literally solve the radical. So you're going to solve, and the final answer is going to be 5. So it looks like a whole bunch of stuff on there, but it simplifies with bed mass. So always use bed mass. All right, once you've got that written down, we're going to go to the top of the next page. Folks, we got lots of time. Here we go. This next one, again, convert. So the first thing we're going to do is we are going to convert this to radical form. So this is going to become 9 over 4, all cubed. And now we're going to solve the 9 and the 4. When we've got radicals in a fraction, we're going to go root 9. Come on now, show up. Root 9 over root 4, all cubed. So you separate the roots and you solve each separately. So now we're going to solve them each. And that's going to become bracket 3 over 2 bracket cubed. Now we're going to solve the cube. So each of them have a hidden 1 on them. Exponent laws say that 3 multiplies in to remove the bracket. So this multiplies into there, whoopsie, to there and to there. And so we end up with 3 cubed over 2 cubed. If it'll let me write, maybe. So 3 cubed over 2 cubed, which we evaluate and solve to be 27 over 8. Final answer. Okay, next one. Whenever we've got an outside fraction that's negative, we flip the inside one, and that tells us that changes it. That was a couple lessons ago. So in order to make this guy change to a positive exponent, I'm just going to flip the inside. These have to flip. And that makes it now a 3 over 2 positive. Next step, change it to a radical. So this is now going to go to radical form. Under the root sign, I've got root 4 over root 9, all cubed. So I'm going to take the root of 4 and the root of 9. I'm not going to split it like I did on the last one. Hopefully you're understanding that it does split and you root them both separately. So I'm going to root him and I'm going to root him. And that's going to give me 2 over 3, still in brackets, now all cubed. And yes, each of them has a hidden 1 on them. So your last step is to take that outside 3 and multiply it in. And that's going to end up 2 cubed over 3 cubed. So it's going to give us roughly the same answer, only the reciprocal of it. So this is going to be 8 over 27. Okay. Moving on down to the middle of the page. All right, finish writing that down.
I kind of barely understood how to do the previous stuff.
All right, it takes time to practice. So how am I going to convert that guy to a radical? What am I going to do? What's he going to look like? If it's a fraction, which number becomes the index? Top or bottom? Bottom. Good. So the bottom's going to slide over and become an index. So I'm going to have cube root r exponent 1. No, you don't have to show the 1, but that's what it's going to become. This guy is going to be 7th root of letter S to the 4. Now, remember, that's going to start as this. It's going to start, and the 4 is going to be like this. But the 4 is going to multiply into that 1. So it's going to end up as S to the 4 underneath. Okay? But when you first start, it's going to end up like that. So sometimes, especially if it's a fraction, if it's a perfect cube or perfect fourth, perfect fifth, you're going to solve that part before you do the outside exponent. So be careful on those. If it's variables, don't worry about it. It just puts it in the spots. So this guy we have to flip over 1 so that our 1 over 6 changes. So we're going to have 1 over letter T to the 1 over 6. And now that's going to convert to a radical. We're going to have 1 over 6th root of letter T exponent 1. Again, you don't have to show the 1s. Unless it's the top of a fraction, then you have to show a 1. It's the only time 1 can't hide. All right, next one, same thing. We got to flip it. So this guy's going to become 1 over V to the 3 over 2. Now we're going to go radical. We're going to make him radical. So 1, come back, come on. 1 over, the index is a 2, V cubed. That'll be your final answer for that one. Okay, we're going to solve each of these, and we're going to find why some of them have no answer.
Could you go back a little bit?
Which one?
Write the answer.
All right, taking a look. Now we're going to put them into powers, those are powers. We're going to solve all 4 of them, and one of them isn't going to solve, and we have to figure out why it isn't. So first of all, we have to see if it's a negative in brackets or is it a floater negative. Do I have a negative on A? No, so I don't have to worry about it. All I've got to do is convert it to radical form. So A is going to be cube root 64 all squared. Cube root 64 is going to solve. So I'm going to solve this guy. He's going to become a 4. And then now it becomes squared. 4 squared. And that's going to give me 16. So I can solve A. A is okay. We are A-okay. All right, B. What kind of negative is B? Is it a floater or a negative base? Negative base. Good. It's a negative base because it's in brackets with a hidden 1 on the 64. That's why. If there was any other exponent other than a 1 with that negative in the bracket, then it's not a negative base. It has to be a hidden 1. Okay, so since that's a negative base, it stays with the 64. So to solve him, we're going to have cube root negative 64, then squared. We can solve cube root 64. It's going to become a negative 4. And again, it's in brackets still, all squared. That will give us a positive 16. Okay, so a floater negative, or sorry, it's not a floater negative, it is a negative base. And I have 2 negatives, so it makes a positive answer. So A and B so far got me the same answer. Let's take a look at C. If I take the square root, converting it to root form, square root 64 all cubed. Can I take the square root of 64? You bet. I can get 8 cubed. Can I solve 8 cubed? Yes. You can get 512. So this guy solves. All right, the next one. Let's try D. So if I look at D, so far A, B, and C worked. So that means D is not going to work. We're going to figure out why though. So if I put him into root form, he's going to be square root negative 64 in brackets all to the 3. Am I allowed to have a negative sign under the bracket with a root?
No.
Not with an even index. So that's why, yeah, that's a no-no. Cannot be done. So this is going to say error. Okay, that one cannot be solved because it's an even index. So B/C is because the index is even. If we look at the question right before it, or sorry, letter B had a cube root. It had an odd number exponent, or sorry, index. That's why we could solve that one. This one with a negative, we can't solve it. It's an even index, an even one of a 2. All right. Last question on this page. It says, write a power that represents the length of the cube. Well, if it's a cube, it literally looks like this. So I've got a cube, and every side, it says it's got a volume of 60 meters squared. Or cubed, pardon me, meters cubed. So that means my length, my width, and my height of my cube, they have to all be the same number because it's a perfect cube. So that means I am cube rooting 60. I need to cube root 60. So what does that look like? Well, that looks like 60 to the 1/3. So we wanted to write it as a power. So A, we've written it as a power. So what would a power be for the surface area? Well, how many sides does a cube have? 6 sides. So my surface area equation for a cube is going to be 6 times side squared, which is basically length times width, but it's side squared because it's the same number. So my surface area equation would look like 6 times 60 to the 1/3 all squared. So the 6 and the squared sign, that is all coming from your surface area equation. So now we need to solve that sucker. Well, what would that actually look like? Well, we got to do brackets. Is there anything in the bracket I could solve? No. It's just one number with an exponent. So that means I got to take my outside exponent in. That's going to remove my bracket. Then it just turns to multiplying by the 6. So this is 2 over 1. I am multiplying them in. When you multiply it in, it's only multiplying to the top number. So this becomes 6 times 60 to the 2/3. And again, it's exponents. So it says now use the calculator. So this is your power. That's what you would write for surface area. Okay, and that would be in meters cubed. If it wants you to solve it, letter C says solve it. So if you are now solving that, we type it in our calculator. So we're all going to go to our calculators and we're going to type in 6 times bracket 60 exponent. Actually, we don't need brackets to begin with, because we need brackets around our fraction. Okay, our exponent, fraction. Whoa, not tan. I'm going to clear that out. Oh. Okay, 6 times, oh, not a bracket again, 60 exponent bracket, your brackets for your fraction, 2 divide 3, close your bracket, enter. It's going to give you 91.95. 957, yes. So the 9 is going to round it up. It says round to the nearest tenth. Well, if you're rounding to a tenth, it goes 957. So that means we've got 91.957. This 5 is going to round that 9 to a 10, which makes it 92. So the answer is actually 92.0 meters cubed. That's what the expression for surface area is. Now, if it wants side length means what are you going to have to do? How do you find the side length of any cube? What is the opposite of cubing something? Cube root. Okay, you're very close. So to get the side length, I'm now going to, in my calculator, take cube root 92. And the side length in my calculator is going to give me 3.9. That's what it's going to round to. All right, following last one, write them with powers of, or write the number 10. So it says a power with an exponent of 1/2. All right. If this, write the number 10 in the following, a power with exponent. Okay, well, I could just go 10 to the 1/2. I could go 1,000 to 1/2. I could go 100 to the 1/2. Put as many zeros as you want. And now it says put an exponent of 3. Okay, well, that would be a power with an exponent of a 3. So 1/3. There we go. Could be anything. Could be 1,000. Could be 1,000,000. I just wanted you to write a power. All right, turn to page 99.
Just
99. We're going to figure it out. It won't take us long. So these are the basic rules that we're going to go over. I know. It's not going to take us long. It's only one page back and front. Here we go. So we're reviewing our product law. When we're multiplying, we add exponents. So that's x to the m plus n, because now we're putting it all together. This is going to be x to the m times n. So that means they sit side by side. This guy to remove is going to be x to the m over y to the n. This one, the integral rule becomes 1 over x to the m, because this is over 1 to start with.
Is the y supposed to have an M or an N?
The y has an n. Or no, m, you're right. Thank you. Okay, the next one. Now we're going to put nth root of m, or sorry, x to the m. Where's my x? Okay, so x to the m, or nth root, x, and m is in the outside of brackets. This one, dividing, we're going to subtract. So this is x to the m subtract n. And this one gets each. They each get the m because they each have hidden ones. So now we're going to get y to the m. Come on. It's not even wanting to write now. Okay. All right. Powers as radicals. Here we go. We're just going to put each of these.
Does that y have an m?
It does. It's just not coming up yet.
I think we need a brain break.
Okay. I'm going to give you a 3-minute brain break in the room. I know. Okay. We're just converting now to radical form. So this is a review of last time. So index, root, x to the 1. If it's a variable, you don't have to put the brackets. You can actually just put the 1 on the x. It'll hide. So this guy will look like 6 root x. The next one, it's got a negative. That negative, because it's a floater and not in brackets, your 4 is an even number. You're going to have an even number radical. So an index with an even number, the negative stays outside. So we're going to have 4th root of y to the 5th power. And the negative stays out. The next one, it's a negative base. The negative goes in because it is an odd. It's going to be an odd. This one here was even. An even index. Now we have an odd index. An odd index means the negative can come under. So I've got negative z, and he's going to now get the 5. Negative bases stay in brackets. So that z's going to stay in brackets. He's a negative base. Same as on D, it's a negative base, so it's staying in brackets. So he's going to look like, but we have to flip him first because we have a negative fraction. He's going to be 1 over cube root in brackets negative z exponent 5. So very similar to the one before, only it was a negative exponent, so we had to flip it and make it a fraction. Okay, next one. We've got 5 and t to the 3/4. Is the exponent attached to the 5? No. So the 5 is not going to be in the radical. It's going to be sitting in front like a coefficient. Because right now the 5 is timesing to the t. So because he's timesing to it, he's going to times to the radical. So we're going to have 5 and then our radical. 4th root t cubed. Okay, so the 5 stays as a coefficient. It was not attached to the exponent. He has a hidden 1 exponent on him. That's why he stays outside the radical. The next one, the 5's in brackets with the t, so it stays with the t. So now we've got 4th root in brackets, bases in brackets, stay in brackets, cubed. Okay? On the bottom, we're combining our exponent laws now. So now we've got exponents, whole number exponents, and exponents that are fractions. So now we got to be able to deal with whole numbers and fractions. So I've got 1 plus 3 over 2. Well, make your 1, if you want to add 1 to it, make him be in the same bottom number. Make him into a fraction. So 1 is equal to, come on, where's 1? It's showing up. 1 is equal to 2 over 2. And the reason I'm saying 2 over 2 is because my bottom number here is a 2. Okay, so you're going to have x to the 3 over 2 timesing by x to the 2 over 2. And now I'm just adding fractions. So now you're just going to go x to the 5 over 2. Now, the easier way, grab your calculator. Put that bracket in fraction, or that fraction in brackets. Go bracket 3 over 2 bracket plus 1. Math enter, enter. It'll do it for you. So you don't have to convert it to this number. The 1 converts to a fraction. If you want to show it longhand, that is what happens. You can do it with your calculator quicker. This guy's going to be 1/3 subtracting 5/3 because you've got the exponent law to subtract because we're dividing. So we're going to get y exponent -4/3. Now, we always have to have positive exponents as our answer. So that's over 1. We're going to flip that guy. So this guy's going to flip upside down. And he's going to end up as 1/y⁴. And you could put him in a radical if you wanted to. So if I put that guy into a radical, he would be this. 1/(y⁴). So both of these are good. Both of these are good answers. Both are correct. Okay, both are correct. Let's take a look at the next one. We're multiplying. So that means we multiply. When we multiply exponents, we multiply top to top, bottom to bottom. So top to top, bottom to bottom. Again, if you forget your multiplying rules or your fraction rules, just put them in brackets in a calculator. It'll do it for you. So we're going to get a to the 2/6. Always reduce your fraction. So that's going to be a to the 1/3. Now, after this, we're going to put it into a root sign because we can. So that's going to be root a to the 1. So both of these are correct. This is supposed to be a 1/3 once it shows up. Okay, on D, we got to flip the inside. Whoopsie. It's not over 1. It is a fraction already. Because it's a fraction, we need to get rid of that negative exponent. So we're going to flip the inside. We're going to get y. Oh, you machine. I love this machine so much. Oy. We're going to get y on top of x squared all to the 1/2. Now, y has a hidden 1. So everything is going to be multiplied. That 1/2 is going to multiply into the bracket. We'll just finish this. We'll finish this one. Okay, so now this is going to give me y. This removes brackets as well. To the 1/2 over x to the 1. Because you're going to get 1/2 times 2. 1/2 times 2 gives you x to the 1. You could convert the top to a radical if you wanted. So you could get root y to the 1 over x to the 1.